Electromagnetic waves are a fundamental concept in physics that have revolutionized the way we understand and interact with the world around us. These waves are a form of energy that travels through space at the speed of light and are created by the interaction of electric and magnetic fields. The idea of electromagnetic waves was first proposed by the Scottish physicist James Clerk Maxwell in the 1860s. Maxwell's equations, a set of four partial differential equations, described the behavior of electric and magnetic fields and their relationship to one another. He showed that these equations predicted the existence of electromagnetic waves, which could travel through space without the need for any physical medium. One of the most important properties of electromagnetic waves is their frequency and wavelength. The frequency of a wave describes how many times it oscillates per second, while the wavelength describes the distance between two consecutive peaks or troughs in the wave. The frequency and wavelength of an electromagnetic wave are related by the speed of light, which is a constant in a vacuum. Electromagnetic waves come in a wide range of frequencies and wavelengths, which we call the electromagnetic spectrum. This spectrum includes radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Each of these types of waves has different properties and interacts with matter in different ways. For example, radio waves have low frequencies and long wavelengths, which make them useful for communication and broadcasting. Microwaves, which have higher frequencies and shorter wavelengths, are used in microwave ovens and telecommunications. Infrared radiation, visible light, and ultraviolet radiation are all forms of electromagnetic radiation that we can see or feel, and they have important applications in lighting, medicine, and astronomy. X-rays and gamma rays have very high frequencies and short wavelengths, which make them useful for medical imaging, radiation therapy, and studying the universe. Electromagnetic waves play a crucial role in our daily lives, from the technology we use to communicate and navigate to the light we see and the heat we feel. Understanding the properties and behavior of these waves is essential for many fields of science and technology and has led to countless discoveries and advancements throughout history. Electromagnetic waves are generated by the acceleration or oscillation of charged particles. When a charged particle, such as an electron, is accelerated or oscillates, it produces a changing electric field, which in turn creates a changing magnetic field. These two fields, electric and magnetic, are interconnected and can generate each other, leading to the propagation of an electromagnetic wave. One common method of generating electromagnetic waves is through the use of an antenna. An antenna is a device that is designed to convert electrical energy into electromagnetic waves and vice versa. When an electrical current is passed through an antenna, it creates a varying electric field, which then generates a magnetic field. These fields combine to create an electromagnetic wave that can travel through space. Another way to generate electromagnetic waves is through the use of lasers. Lasers produce coherent and monochromatic light that consists of electromagnetic waves of a single frequency and wavelength. Lasers generate electromagnetic waves through the process of stimulated emission, where an excited atom or molecule is triggered to emit a photon of light that matches the frequency of the incoming photon. In addition to antennas and lasers, electromagnetic waves can also be generated through other natural and artificial processes. Lightning, for example, generates electromagnetic waves through the rapid discharge of electrical energy in the atmosphere. Electromagnetic waves are also produced by electronic devices such as cell phones, computers, and televisions. The frequency and wavelength of the electromagnetic wave generated depend on the frequency and nature of the acceleration or oscillation of the charged particles. By controlling these factors, scientists and engineers can create electromagnetic waves with specific properties that are suitable for various applications, including communication, medical imaging, and materials testing, among others. Electromagnetic waves have several key characteristics that define their behavior and properties. These characteristics include wave speed. Electromagnetic waves travel at a constant speed of 299,792,458 meters per second, or approximately 186,282 miles per second, in a vacuum. Frequency. The frequency of an electromagnetic wave refers to the number of waves that pass a given point per second. It is measured in Hz, Hz. The frequency is inversely proportional to the wavelength of the wave, meaning that higher frequencies correspond to shorter wavelengths and vice versa. Wavelength. The wavelength of an electromagnetic wave refers to the distance between two consecutive peaks or troughs in the wave. It is measured in meters or other units of length. The wavelength is inversely proportional to the frequency of the wave, meaning that longer wavelengths correspond to lower frequencies and vice versa. Amplitude. The amplitude of an electromagnetic wave refers to the height or strength of the wave. It is measured in units of electric field strength or magnetic field strength, depending on the type of wave. Polarization. Electromagnetic waves can be polarized, which means that the electric and magnetic fields oscillate in a specific direction. Polarization can be linear, circular, or elliptical. Interaction with matter. Electromagnetic waves can interact with matter in various ways, depending on their frequency and other properties. For example, low-frequency waves such as radio waves can pass through buildings and other obstacles, while high-frequency waves such as X-rays and gamma rays can penetrate solid objects and cause ionization in biological tissues. Energy and intensity. Electromagnetic waves carry energy that can be transferred to matter. The intensity of an electromagnetic wave refers to the amount of energy that passes through a given area per unit time. It is proportional to the square of the amplitude of the wave and inversely proportional to the square of the distance from the source. Overall, the characteristics of electromagnetic waves are essential to their behavior and applications in various fields, including communication, medicine, and astronomy. Electromagnetic waves have numerous applications and uses in various fields. Some of the key applications and uses of electromagnetic waves are communication. Electromagnetic waves are used for communication through various means such as radio, television, satellite, and cellular technology. These waves carry information in the form of radio signals and microwaves, allowing people to communicate over long distances. Medical imaging. Electromagnetic waves, such as X-rays, ultrasound, and magnetic resonance imaging, MRI, are used in medical imaging to visualize internal structures of the body. These waves can provide detailed images of bones, soft tissues, and organs, enabling doctors to diagnose and treat diseases. Remote sensing. Electromagnetic waves are used to remotely sense and monitor various environmental and geospatial parameters. For example, satellites use electromagnetic waves to measure the temperature of the Earth's surface, the moisture content of the soil, and the atmospheric composition, among other things. Astronomy. Electromagnetic waves are used to study and understand the universe. Telescopes and observatories use electromagnetic waves of different wavelengths to observe celestial objects such as stars, galaxies, and black holes. Materials testing. Electromagnetic waves can be used for materials testing and quality control in industries such as aerospace, automotive, and construction. For example, ultrasonic waves can be used to detect flaws and defects in materials such as metal and concrete. Energy. Electromagnetic waves can be harnessed for energy production through solar panels and wind turbines. Solar panels convert electromagnetic waves from the sun into electrical energy, while wind turbines convert the kinetic energy of wind into electrical energy. Entertainment. Electromagnetic waves are used for entertainment purposes, such as in music and film. Radio waves are used to transmit music and other audio content, while television and streaming services use electromagnetic waves to transmit video content. Overall, the applications and uses of electromagnetic waves are diverse and significant in various fields. Their ability to transmit information, sense the environment, visualize internal structures, and generate energy has transformed the modern world and continues to shape our daily lives.